Hi guys, welcome back to today's video. We tested the charging compatibility of this vivo 80W flash charge charger, which is pretty good. You can click the upper right corner to take a look. Today, Charger Lab is going to take it apart and take a look at what's inside. Here are some specs info. Model is V8060L0A2. It can support input of 100 to 240 volts, 50 or 60 Hz, 2.5 amp, and it can also support vivo flash charge, PD and PPS. The manufacturer is OPPO technology. It's equipped with dual wide USB-C ports. The size of the charger is about 31 and 40 and 64 mm. Weight is about 122 grams. So its power density can reach 1.01 watts cubic centimeter. And the size is much smaller than Apple 87 watts charger. Next, let's try to take it apart using the cutting machine and check out what's inside of this charger. Firstly, we need to remove the white plastic. And then take out the internal PCB module. It's wrapped with brass heatsink to enhance heat dissipation. The black isolation plate is under heatsink. The red and black wires are connected to two different PCBs. Another white isolation plate and metal heatsink are on the back. The input filter circuit is on the left, the transformer is in the middle, and the secondary step-down circuits are on the right. The entire PCB module is filled with silicon adhesives. Some SMD components are on the back. Charger Lab found it adopts QR flyback topology with a fixed voltage. The secondary step-down circuit can adjust the output voltage. Let's start from the input to introduce all components. This is a small PCB for input, and we can find the fuse, common mode choke, NTC Thermistor, and X capacitor. Firstly, the current will pass through the fuse, and then it'll go through the EMI filter circuit. The time delay fuse is from Better Electronics, 3.15 amp, 250 volts. And here is the common mode choke. The NTC Thermistor is from JOYIN, which can suppress the inrush current. The resistance is 2.5 ohm. The safety X capacitor is from STE Electronics, 0.1 microfarad. After the EMI filtering, two bridge rectifiers can convert AC into pulsed DC. They're on the back of the small PCB, which can evenly dissipate heat. The filter capacitor can filter the pulsed DC into pure DC. Those three electrolytic capacitors are from TEAPO, 15 microfarad, 400 volts. Two slightly larger capacitors are also from TEAPO, 27 microfarad, 400 volts, and 99 microfarad in total. The master control chip controls the switching transistor to convert DC to AC and send it to the transformer. The master control chip is from Richtek, and this tiny TEAPO capacitor can power master control chip, 4.7 microfarad, 50 volts. The primary GAN IC is from Navitas NV6136A, which adopts QFN 6x8 package. It integrates driver and lonely list current sampling circuit for higher integration, 170 microfarad, 650 volts. Here is the transformer, which is covered with a plastic shell for insulation. Here is the Everlight EL1019 Optocoupler, used for feedback of output voltage. Two SMD Y capacitors are from TRX TBY2331KB and connected in series. And then the current from transformer will filter out by solid capacitor after synchronous rectification. Remove the front components and small PCB. A synchronous rectifier controller is on the right. Model is MPS MP6908. It supports DCM, CCM, and QR modes. The synchronous rectifier is from Richtek and adopts PDFN5060X package, 100 volts 3.8 mA. Both the blue and red output solid capacitors are from Barrel, 560 microfarad 25 volts. Next is equipped with two box circuits composed of MOSFET, inductor, capacitors, etc. The protocol chip controls the output voltage of each port. Those four small PCBs for output are vertically soldered on main PCB, which can improve space utilization. Let's take a closer look at the small PCB for output. The synchronous buck controller and two buck MOSFETs are on the back. The output voltage can be changed by protocol chip. The synchronous rectifier controller comes from South chip SC8002. The input voltage can be up to 36 volts and can be configured as dual outputs or single output. Both synchronous buck MOSFETs are from Richtek and adopt a PDFN5x6 package, 30 volts 5.4 mA. There is a buck inductor on the back of the PCB. Here is the USB-C receptacle, which is protected by the double-layer casing. The V-bus MOSFET is also from Richtek and adopts PDFN3333 package, 30 volts 5.2 mA. The protocol chip is from Richtek and adopts QFN package. And the second small PCB for output is the same. Well, that's all components of this vivo 80W charger. The mass control chip and protocol chip are from Richtek, which can control the output voltage of each port. And the internal layout is very compact. The vertical PCB design can significantly improve space utilization, since it can support vivo flash charge, PD, and PPS protocols, so it can be widely used in your devices from Vivo and other brands, which is an advantage compared to the OPPO 80W charger. And you can also fast charge two devices at the same time, pretty convenient. Okay, that's all for today's video. Please drop a like, leave your comments, and subscribe to us. I'll catch you guys in the next video. Bye!